Hello and welcome to Higher Maths, Polynomials and Quadratics. We are looking at finding intersections of curves, essentially finding out where curves cross or where a straight line and a curve crosses. So we're going to go straight into examples. So find the points of intersection of the line y equals 4x minus 4 and the parabola y equals 2x squared minus 2x minus 12. So at the side here, I've just done a sketch of what's actually happening. So it says the points of intersection. So there's going to be more than one point. So I know it's going to cross in two different places because we have a straight line and a parabola. If I just said the point of intersection, I would infer from the question that I would be looking for a tangent to the curve, a line that's just touching the curve there. But because it says the points of intersection, I'm looking for 2 points there. So I've got a straight line with a positive gradient, and I've got a parabola with a positive coefficient of x squared, so I know it'll be a smiley face parabola. So how do I find these points? Well, we equate the curves. At this point here, and at this point here, I know that the y-coordinate in both of these equations are equal. So writing y equals y does not really help us. However, if the y-coordinates are equal at these 2 points, then also 2x squared minus 2x minus 12 must equal 4x minus 4 at this point and at this point. So we're just equating 2x squared minus 2x minus 12 with 4x minus 4. After that, we're back into National 5 Maths. We are going to collect all the terms to one side, and then we are going to solve the equation by factorizing. So we'll take out a common factor of 2 to make it easier to factorize. Then we end up with x squared minus 3x minus 4 equals 0 in the bracket here, which will go to x minus 4x plus 1. So solve each bracket to equal 0. Now 2 can never be 0, so the 2 is still there, but that cannot be 0. I've got 2 multiplied by this bracket, multiplied by that bracket equals 0. So the 2 is never 0, so one of the brackets must be 0. So we could have x equals 4 or x equals negative 1. So I have the x-coordinates of these 2 points of intersection, but not the y-coordinates yet. How do I find the y-coordinates? I substitute the x-coordinate into y equals. So I could use either one, but the substituting into y equals 4x minus 4 will be less work. So substitute negative 1 in, and we get negative 8 for the y-coordinate. Substitute 4 in, we get 12 for the y-coordinate. So the 2 points are negative 1, negative 8, and 4, 12. Question number 2. Find the coordinates of the points of intersection of the cubic and the line y equals negative 3x plus 5. So a cubic equation, a cubic curve, guys, will look like this, or something similar to that. We'll talk about that more in a later topic. I'm just trying to give the visual of what's actually happening here. And I have a straight line, so what could happen is it could cross once, or it could cross once and then hit there, which would give a repeated root, or it could cross 3 times, or there could be a repeated root, then cross there, or it could just cross once here. So there's many different things that could happen there. We're going to use exactly the same method we used on the previous question. So we are going to equate and set everything equal to 0. And then I'm going to do synthetic division. I'm looking for the factors of minus 15 here. So I'm going to start with 1 as always. And fortunately enough, 1 works. So remember, we need to make this statement for a mark. If I'm not making that statement there, I'm throwing away a mark. Okay? So we need to make this statement very, very important. Then after that, we're going to have x minus 1 bracket x squared minus 8x plus 15, which factorizes. So we're going to have this triple bracket here. Solve each of those equal to 0. And then find the corresponding y coordinates. So if I want the value of y when x is 1, I just substitute 1 into y equals. Same again for 3 and 5, which gives me the points of intersection 1, 2, 3, negative 4, and 5, negative 10. So key skills, what have I done? I've equated, then I'm just solving using synthetic division after that. We're back onto synthetic division and factorizing cubics.